example, we're given the distribution of goals scored by time by the local football club. And the first thing we've been asked to do is illustrate the data by means of a histogram. So the first thing I'm going to do is rewrite my table out. So I've got time. So we have 0 to 15, 15 to 30, 30 to 45, 45 to 60, 60 to 75, and 75 to 90. And I'm also going to put in the goals, which are 6, 5, 14, 22, 15, and 10. And to calculate the frequency density, which is what's plotted on a histogram, I need to know the class widths. So the class width is basically the difference between the minimum value here and the maximum value here. So this one is 15, as is this one, as is actually all of them. This isn't always the case, so you just need to make sure you read the question and actually check what your class width is. Now, frequency density, that's defined as the number, so in this case number of goals, divided by the class width. So the first one is 6 over 15, which is 0.4, and 5 over 15, which is 0.33. Then we have 14 over 15, which is 0.93, 22 over 15, which is 1.47, 15 over 15, well that's just 1, and 10 over 15, which is 0.67. So I now have all the information I need to sketch my histogram, but I'm going to leave my table because I need to extend this later on to work out the mean and standard deviation. So plotting my histogram, okay, I'm going to draw a rough axis. Now when you do this, you should use lined paper, a pencil and a ruler. Make sure all your lines are straight and your axes are spaced out correctly, but we can only draw a rough one on here. So on our x-axis, we're going to have the time, and that is in minutes. So we have 0, 15, 30, 45, 60, 75, and 90. And then on the y-axis, we have the frequency density. So that's 0, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, and then we'll go up to 1.6. So all we do is now plot the frequency density. So between 0 and 15 we had a frequency density of 0.4. So we just draw a bar like so. Between 15 and 30 we have a frequency density of 0.33, so that's roughly like so. 30 to 45, frequency density of 0.93, so that's roughly here. 45 to 60, we have frequency density of 1.47, so that's about here. For 60 to 75, we have a frequency density of 1. And finally, for 75 to 90, we have a frequency density of 0.67. So that's roughly here. So we've drawn our histogram. We should just give it a title, so it's histogram of the distribution of goals scored by time. Okay, so we've done this first part. We've illustrated the data by means of a histogram. Now we need to identify the type of skewness. So we can see that the data is ever so slightly more to the right. So I would say it's ever so slightly negatively skewed. And that is because there is more data to the right. So in this next part, I've been asked to calculate an estimate for the mean and standard deviation. Now, as I've got group data, I need to introduce the midpoint of my group. So the midpoint is the average of the maximum value and the smallest value in the group. So the average of 15 and 0 is 7.5. So my midpoint is 7.5. For the next one, it's 22.5, then 37.5, 52.5, 67.5, and 82.5. So I've calculated my midpoint. My next thing I need to work out is the midpoint times the frequency. So in this case, it is 6 times 7.5. So 6 times 7.5 is 45. For the next one, it's 5 times 22.5, which is 112.5. And following this on, so 14 times 37.5 for the next one will give me 525. For the next one, it will be 1,155. The one after that will be 1,012.5. And the final one will be 825. And then I do need to know the sum of all of these. So at the end, the summation of all of these will be 3,675. So that's my midpoint times frequency. I also need to know the midpoint squared times frequency for the standard deviation. So we'll do that now. Midpoint squared times frequency. So that tells us my midpoint squared, so that's 7.5 squared times 6. So that's going to give me 337.5. For the next one, I'm going to get 2,531.25, then 19,687.5, then 60,637.5, then 68,343.75, and the last one will be 68,062.5. And again, I also need to know the sum of all of these. So the sum of all of these will be 219,600. So you see, when you're working out the mean and standard deviation for group data, it's best to do it all in a table. So I can now work out my mean. So my mean, as I know, is the sum of all divided by the number. So the sum of all of them, I said, is 3,675, and the number of them is 72. And to calculate the number of them, it is just adding up all of these. So that gives a value of 51.04. So the average time a goal was scored, or the mean value, was 51.04 minutes. Now the standard deviation, to calculate that, it is the square root of the sum of midpoint squared times frequency. So it is 219,600 divided by 72, the number, minus the mean squared. So it's 3,675 over 72, all squared. And when we plug this into our calculator, we get 21.09. So I can say that the mean was 51.04 and my standard deviation is 21.09. So the final thing I've been asked to do is use linear interpolation to calculate an estimate for the median. So to do that, I'm going to say the median, well, that is the 72 plus 1 over 2 term. So we're looking for the 36.5 value. So the 36.5 value, well, that comes between 36 and 37. So between 36 and 37, that is going to be in this group here. So what I do, I draw a box. So the 45th minute and the 60th minute, and that is 25 up to the 47th value. So I have 22 values here, which I can see from here. There's 22 values here. So all I now need to do is use linear interpolation to calculate the median. So what I say is I start off at 45 and then I want to go across till I get to the 36.5 value. So it's somewhere around here. Okay, so I need to go over from 25 to 36.5, so it's 36.5 minus 25. That tells me how many steps I need to go across till I get to my value. And then I need to know how long each step is. And so how long is each step? Well, the total distance is 15 over 22. So that gives me 45 plus 172.5 over 22, which is 52.84. So I say that the median is 52.84. 52.84. So I've drawn my histogram, I've identified the skewness, I've calculated the mean and standard deviation, and I've used linear interpolation to estimate the median.